All right, I'm going to make this one as quick as possible. So this is chapter 8, right triangles and trigonometry, and the first section, which just has to do with geometric mean. So the goal here is to calculate geometric mean using triangles or other numbers. So we're just going to do it with the other numbers here. So I'm not going to do it with triangles because I don't want to give you too much of a break. So we're just going to skip that part, and then we can go from there. So this is all that you really need to know. So to tell you the difference between arithmetic mean and geometric mean, arithmetic mean is what you've used as mean before. Mean meaning average. So an arithmetic mean is just the average of all the numbers. So if you were going to calculate this, see, this is just an average of numbers. You know this. If I wanted to take the average of 2 and 3 and 5, I would add 2 plus 3 plus 5 divided by 3, and you already know how to do this. 5 and 5 is 10. 10 divided by 3 comes out to something like 3.3. So that's how you find the average with arithmetic mean. Geometric mean is a little bit different. Geometric mean, so the mean the geometric mean of two numbers means they're proportional to the same number. So again, the geometric mean of two numbers means they're proportional to the same number. So the way that looks, the geometric mean, which I'll use in this case as m for mean. So the geometric mean of two other numbers, so the geometric mean would be proportional to those other two numbers. So I'll call those two other numbers x and y. So that's kind of what the setup would look like. You set up a proportion, they're proportional to both numbers, and that's what it would look like. So I'll breeze through 4 of these examples pretty quick. I'll show you how to find geometric mean of two numbers, and then that'll be it. You can use this for some stuff in right triangles that are similar, but we don't really have time to go through all that, and you'll probably thank me for not doing that. So I'll scroll down so that you can see all of this stuff here. So the geometric mean of 4 and 8, actually, might as well just leave that. So geometric mean of 4 and 8. So the mean of 4 and 8, I'd be able to calculate this. I cross multiply, m squared equals 32, which means m equals the square root of 32. Now, simplifying 32 is the part that some of you guys are going to have a hard time with. So I usually factor it down and check how many factors there are. You can also just split it up into square roots. So splitting it up into some numbers that I know I can take the square root of would be something like 16 and 2, because then I could just say that that's 4 square roots of 2. The other way that some people do this is if you factor 32 down. 32 is, you could even say 8 and 4, which means this is 2 and 2, and this is 4 and 2. And then I would say 4 is 2 and 2. So I can take out a factor of 4 here, and I can take out a factor of 4 here. So I can say that, I can take those out of the square roots. So breaking that down, it means that that's 2 times the square root of 2 that's left, which is 4 square roots of 2. So whatever way makes more sense to you, I just want to show you both. So sometimes I do them either way. So for example, on this next one, and if I wanted to find the geometric mean of 9 and 12, it doesn't matter which way you set it up. I could say that 9 over m equals m over 12, and it's the same thing. When you cross multiply, you get m squared equals 9 times 12, which is, well, 10 times 12 is 120, so 9 times 12 would have to be 108, which means m is the square root of 108. So you're going to need to reduce that. So you take 108 and you break it down. We know that you can break down 108 to 9 and 12. We just multiplied it to that. 9 gives you 2 3s, and 12 gives you a 4 and a 3. So I see that here I could take the square root of 9 and get 3, and here I could take the square root of 4 and get 2. So a good way to write this would be the square root of 9 times the square root of 4 times the square root of 3. Square root of 9 is 3, square root of 4 is 2, and then you still have this. So that's 6 square roots of 3. If the simplifying the square root part is hard for you, you could Google simplifying square roots, and there's a million different things that will come up, and you can see some examples of that. Purplemath.com has a lot of good examples of that kind of stuff. So you can go through that. I don't know what's easy for you or hard for you. So if I do these two numbers, m over 7 equals 25 over m. So m squared equals 25 times 7. M equals the square root of 25 times 7. You'll notice that sometimes I don't even multiply these out because I know that I'm going to have to break them down anyway after. So when I go to simplify the square root, I can say that that's 25 times the square root of 7, and then that's 5 square roots of 7. So if it's a little fast, you can watch it back and see exactly how I did that. Last one here, I just wanted to put one with some funny square roots that was a little bit tougher. So the setup is the exact same thing. M over the square root of 32 equals, what is this, the square root of 14 over m. M squared is equal to square root of 32 times the square root of 14. Now, when you go to take the square root of these, it's going to be a little bit tougher because it's going to look a little weird. So what do we got here? If I could do 32 times 14, I've got 30, well, I won't even, let's make that the square root of 32 and 14, and then break these down. I haven't even taken the square root yet. So I could break these down. This is 16 times 2 times 14. I know that the square root of 16 is 4, so I might as well leave that. And then 14 is 2 and 7. So these two 2's I can take out as well. So maybe I should write this as the square root of 16, and then the square root of 4, and then the square root of 7. So I end up with, what is that, 4 times 2 times the square root of 7, so 8 square roots of 7. Now I realize in my answers over here, I really, that's not exactly it yet. So m squared, so far, I have never actually taken the square root yet, equals 8 square roots of 7. At this point, this is why I put this one last, because it's a little weird. You'd have to take the square root of that. So I'm not going to make you simplify something crazy like this. I just wanted to show you that it is possible, and you can break this down a little bit further. So for those of you who are interested in the algebra, so the 8 you would break down to 2 square roots of 2. So you'd have 2 square roots of 2 for that, and then you'd still have the square root of 7 in there. So anyways, don't worry about something like this. It's not going to be that difficult. But I just want to show you that you could do it with other numbers. So this one would actually be, that answer would be a little bit different. So anyways, that's it. So geometric mean, that's the only part that we're going to do for 8.1.